Welcome to my channel. Today we will learn about work, energy and power, which is the second chapter of ICSE Physics Class 10th. जैसा हमें पता है कि हम लोग अपने डेली लाइफ में बात करते हैं वर्क के बारे में. What is work? What is work? Everybody say, I'm busy in work. I'm busy in work. So what is work? In terms of physics, work is defined as the product of force and displacement in the direction of applied force. Once again, what is work done? Work done is product of force and displacement in the direction of applied force. Like, we can discuss it by the different examples. Like, I will leave it from here, so it will come down. It means I am going to hold it at this position, then definitely I have performed some work to hold this pen at this height. That is work done. Against the gravity. It is also kind of work. Another example we can take, suppose we are pushing the wall, but wall is not going to be displaced. So no work is being done in that case. You are pushing a car and car is moving ahead. It means you are doing work. So what is the observation during work done? If we are applying the force and displacement is being, initially it is at this position, we are going to hold it. So I am applying the force to hold it and it has been displaced from here to here. ये इसका displacement हुआ. Then definitely I did some work. So what is common thing during work done? If work is going to be performed or being done, two things are there. One, we are applying the force to hold it, and second, it has displaces from one position to another position. So again, work done depend on the two factors. One is the force and second is the displacement. If we are applying the force and displacement is being done, then we are doing work. So these are the two conditions. And ideally, in physics, we define work done as it is the product of force and displacement in the direction of applied force. Displacement should be in direction of applied force. So regarding that one, we can take one more example. Suppose we are pushing the wall, but wall does not displaces. Then we are doing work? No, because displacement is 0. One more example I will tell. Very interesting fact is that suppose any coolie is there. He is carrying luggage on his head. He is carrying some luggage on his head. And as he is walking on the road, during walking on the road, he is not doing work. Although he having weight, the force is there to downward direction and displacement is being there, but no work is being done. So in practical way we will talk कि अगर हम लोग किसी कुली को बोलते हैं कि आप ये लगेज लेके आप चलो, और उसको हम पूछे कि सिर्फ उठाने का लगेज और रखने का कितना पैसा लोगे और बाकी चलना 2 किलोमीटर है, तो हम उसको ये बोले कि भाई जब आप सर पे लगेज रखते हो एंड यू आर प्रोसीडिंग टू अ सर्टेन डिस्टेंस, देन यू आर नॉट डूइंग वर्क. So practically we can't say by that person, but definitely according to physics he is not doing work when he is carrying luggage on his head. We will discuss about it further. So basic concept you people have, I think so, understood कि what is work done according to physics. Work done is defined as the product of force and displacement in the direction of applied force. So let us discuss what is the theory regarding that one. So work, what is work? Work, simply definition is there. The amount of work done by a force is equals to the product of what? Force and displacement of the point of the application of the force in the direction of force. It is compulsory. Displacement should be in direction of applied force. Okay. So as we can see these examples, one person is there, he is pushing the wall, but wall does not move, no motion in the wall. So what we can say, displacement in this case is 0, and as displacement is 0, work done will be 0. Work done will be 0. We are pushing, suppose any person is pushing a car and there is the motion in the car, then this person is doing work. So simply, what is work done? Work done, for work done, two things are there. One is displacement should be there, and second is force should be applied on the body. Now measures of work. Already I tell you what factors are there which is responsible for the work done. So measurement of work. Measurement of work. The amount of work done by a body on a body depends on two factors. One is magnitude of force applied, and second is the displacement produced. Again, two factors, force and displacement. So work done depend on two factors. One is force, another is displacement. Already in previous classes like 8th and 9th, you people have studied work done. Work done simply is equals to force into displacement. Displacement. So force is F into displacement, sometimes S or sometimes D. So work is F into S or F into D. We have studied. But as I was given the example of the coolie, while coolie is carrying luggage on his head, he is not doing work. And what is the reason behind that? Reason is that angle will be 90 degree between the force and displacement, then no work is done. So apart from this formula, today we will discuss and derive the expression for new formula, which is W is equals to Fs cos theta. From where it has come and what is the condition. So regarding that one, in that case, again I will tell you why coolie does not work during that condition. So let us see. The amount of work done by a force is equals to the product of the force and displacement of the point of application of the force in the direction of force. So work done is equals to force into displacement of the point of application of force in the direction of force. Simple way. Apart from this, I can say simply work done is defined as the product of force and displacement in the direction of applied force. Means force and displacement both are in same direction, then work will be done. So simple way. Okay, so we have to derive an expression for the W is equals to Fs cos theta. As earlier I tell you कि cos theta is also a factor from where it has come. So we can get the expression for work by two different ways. One way is by finding the component of displacement along the force. What I have mentioned already, I can write here again that part. What is work done? Work done is force, product of force and displacement in the direction of applied force. This word is very important. In the direction of applied force. So as you can see, along the force, we have to find out the component along the force. What we have in this diagram, just concentrate. We'll concentrate over here. Okay, suppose there is any inclined surface AC. AC is inclined surface and this is the horizontal surface AB. Inclined surface makes an angle theta with the horizontal surface. And here any block is there. On this block we are applying force F. Then this block displaces and it comes to this position. Mean to say this block moved to here. And during that one displacement is S. This is the displacement. Direction of force is this and direction of displacement is this. But when work will be said to be done, work done is equals to product of force and displacement, and condition is that displacement should be in the direction of applied force. Again I will tell you, force is to this direction but displacement is being to this direction. Directions are different. So we have to find out direction of displacement in the direction of force. So what we have to do in this case, we can say in triangle we have AC is equals to S, that is the displacement, and F is of course force, and AB is the component along the force. So in this triangle we can say in right angled triangle, which triangle? ABC. In this triangle cos theta we will find out. Why we will find out the cos theta? Why we are interested to find out the cos theta? We know this component as S, displacement, AC. But direction of force is this. So direction of displacement should be this one, along the force. So we have to find out the component of displacement as in direction of force. So that is AB. So AB is to be found out and AC is known to us. So what is the relation between AB and AC? We can get it by the cos theta. And what is the cos theta? Again we will say, what is the cos theta? Cos theta is adjacent upon hypotenuse. So cos theta will be AB by AC. So we will write AB by AC. But AB is to be find out as, and AC is displacement S. So AB becomes S cos theta. And what is work done? Since work done, I will take it as equation 1. Since work done is force into displacement in the direction of applied force. Displacement in the direction of applied force. So it will be force into displacement in the direction of applied force. That's component we get already. that's component displacement. Component of this displacement is AB. So we will get F into AB. F into AB. But what is AB? AB is S cos theta. So W will be F S cos theta. Fs cos theta. So that expression was to be progressed. We can write from equation 1. So this expression is over. That's so simple. Next, it was the expression for work done. Work done. W is Fs cos theta. Now we'll not say only work done is equals to F into S. No, it is Fs cos theta. So next way to find out Fs cos theta by finding the component of force. Component of force. That was the component of displacement. It was the component of displacement. Now we are interested to find out the component of force. Component of force. So diagram is very important. Component of force along the displacement. So in this case again diagram is same. This is the horizontal surface. This is the inclined surface. This angle is theta. As we apply the force on this block moves from here to here, then displacement is S. And in that case, we are observing this is the direction of force. So displacement we have to find out, we will find out the component of force. So we do the construction over here, we will do the construction over here, and according to that, we have to find out the component of F along the displacement. Component of F along the displacement. This is the displacement. F is this one. So we are interested to find out the component of force along the displacement. Along the displacement. Along this. Now this and this both are in same direction. So for that also we will take in triangle PNA. PNA. In that right angle triangle, we have PA. Already we have PA. PA is F and NA is to be find out. So in this triangle, again we will find out the cos theta. Cos theta is what? Adjacent upon hypotenuse. Adjacent is AN upon hypotenuse is AP or PA. So AN is to be find out and AP is F. So again AN will be F cos theta. F cos theta. So now AN is what? It is the component of force. AN is the component of force. Component of force. So since work done is force into displacement, but force is F cos theta and displacement. In this case again see force and displacement both are in same direction. So we will take it as AN. We'll take it as AN into cos AN into S. But AN is F cos theta into S. So it becomes again Fs cos theta. It is W. So this is the final expression for W is equals to Fs cos theta. So what we have to remember now onwards, work done is Fs cos theta. Fs cos theta. Now there are some special cases. वही कुली वाला एग्जाम्पल और भी एग्जाम्पल्स दैट विल सी. तो फर्स्ट केस में बी देयर हम लोग केसेस ले रहे हैं. तो फर्स्ट केस आई विल टेक case 1, if theta is equals to 0, then cos 0 is what? Cos 0 is 1. So since W is equals to Fs cos theta, so it will be Fs cos 0, but cos 0 is 1, so it will be F into S. It is work done. It means what? What we have to remember? In this case, what is our observation? Displacement is being in the direction of applied force. Then and only then theta will be 0. Example we can take, suppose any car is there and we are pushing the car. So we are applying the force and displacement is also being in the same direction of applied force. Displacement and force both are in same direction, so theta will be 0. And cos 0 is 1, so work done will be F into S. Keep that. Now second case, case 2, I will take if theta is equals to 90 degree. So we know cos 90 is 0. So we know since W is equals to Fs cos theta, so here it will be W is equals to Fs cos 90, and cos 90 is 0, so it will be 0. So work done will be 0. So this may be the case of cooling. We will see it by examples. Suppose coolie is there, that is carrying luggage on his head. Is carrying luggage on his head, and he is proceeding to this direction. So load means whatever load it have, load means force. So force is mg, and that's direction we can represent like this. Load or force is as mg in this case. This force is mg. And as he is moving to this direction and he reaches over here, again, over here. So in that case, displacement is being as S. S is the displacement. S is the displacement. S is the displacement. S is the displacement. So in that case, again theta becomes 90 degree. So this is the example of that part. And one more case may be there. Next case, what it may be? Next case, case 3. Third case, case 3. If theta is equals to 180 degree, then we know cos 180 is minus 1. Cos 180 is minus 1. We'll take over here. Cos 180 as minus 1. And since W is equals to Fs cos theta, so W will be Fs cos 180, and cos 180 is minus, so work done will be negative. What example we can give regarding the negative work done? Suppose you are pushing a car and car is in reverse gear. So as you are applying the force to this direction on the car and car is pushing you back. So you are applying the force to this direction and displacement is being to this direction. Direction of force, direction of displacement. Both are exactly in opposite direction. So theta will be 180 and work done will be negative. So work done by us on the car will be negative, and that is given by this expression. Next part, we have work done by a variable force. So simply, what is our observation? it is the displacement axis and it is the axis of force. And we have to find out work done. So we know work done is, number of times we have discussed already, work done is force into displacement. Into means area. If area is there, then multiplication. So in this graph we will find out work done is equals to, in this case work done will be equals to area of triangle, about shaded part we are talking, OSA, and we know area of triangle is 1/2 into base is OS, which is the displacement, into height is AB, so 1/2 into OS is displacement into height is force. So it is 1/2 into force into displacement. We are talking about here, about this diagram part. As we can see displacement is S in this case, and this AB is nothing but axis of force, so this AB is force. So 1/2 into F into S. Now next part, work done by a constant force. Force is constant. If anywhere we discuss about the graph of any part which is constant, so in that case what is our observation? That like constant force is here, so force will be parallel to the x-axis. So here we have, this is the axis of displacement and this is the axis of force. So work done by a constant force is constant, so this kind of graph we are getting, and in this case work done by the constant force will be area of this part. So again we can write work done will be equals to area of rectangle what OSBA. So area is length into breadth, of course it is OS into BC, but OS is, what is OS? OS is displacement S and BC is force F. So it is S into F, S into F, S into F, or it is F into S. So work done will be force into displacement. Next is units of work. Units of work. So we know the relation work, since work is force into displacement, so unit of work, that will be unit of force into unit of displacement. Unit of force into unit of displacement. And we know unit of force is Newton into unit of displacement is meter, and this term itself is joule. So unit of work is Newton meter or it is joule. Newton meter or joule. Another unit we can write. What is unit of force? Force is we can write over here. Since force is mass into acceleration, so W will be F into S, but F is mass into acceleration. I will take it capital M, mass into acceleration into S. Unit of mass is kilogram, acceleration is meter per second square, and displacement, this is displacement, it's not second, it having unit meter, so it becomes kilogram meter square per second square. So another unit we can write joule. Joule will be same as the kilogram meter square per second square. So both the units are there. Now, how we can define the term 1 joule? 1 joule, 1 joule. We will read the definitions later on. Just we can think about it. What will be unit of, what is 1 joule? So we know since W is F into S, so unit of work done is what? Joule. Unit of work done is joule. So unit 1 joule, we can write 1 joule. Therefore 1 joule will be 1 Newton into 1 meter. 1 joule will be 1 Newton into 1 meter. So when the work will be said as 1 joule, very simple, as per the definition or expression for work done, 1 joule of work will be said to be done when 1 Newton of force is applied to any body and body get displaced by 1 meter. Simple way. If 1 Newton of force I am applying on this body and this body displaces by 1 meter. So force should be 1 Newton and displacement should be 1 meter. Then whatever work will be done by me, that will be 1 joule. So this is the definition of 1 joule. 1 joule of work is said to be done when a force of 1 Newton, that is here, displaces a body through a distance of, apart from the distance we can write displacement also, displacement of 1 meter in its own direction. Own direction in sense in which direction we are applying the force, displacement is also being in same direction. So this is the concept of 1 joule. So 1 joule of work will be said to be done when a force of 1 Newton displaces a body through a distance of or through a displacement of 1 meter, or body get displaces by 1 meter. That is the concept of 1 joule. Now we have relationship between joule and erg. Relationship between joule and erg. So joule and erg. So we will start with the joule directly. What is 1 joule? So since 1 joule is equals to 1 Newton into 1 meter. But 1 Newton is I can do it by two different ways. 1 Newton is 1 kg into 1 meter per second square into 1 meter. So 1 kg is 1000 gram, 1 meter is 100 centimeter into 1 second square into 1 meter is again 100 centimeter. So it will be 10 raised to 3, 10 raised to 5, 10 raised to 7. So it will be 10 raised to 7 gram centimeter into centimeter becomes centimeter square, and centimeter square into per second square. So this term is erg. So 1 joule is 10 raised to 7 erg. So what is 1 erg? 1 erg, this is done actually. 1 erg is 1 gram into 1 centimeter square into 1 second square. This is erg. So this is the relationship between joule and erg. This part probably is little bit we can understand it by this reason I can give. Since work done is force into displacement, but force is mass into acceleration into displacement, and unit is kilogram, unit of acceleration is meter per second square, and again unit of displacement is meter, so it becomes kilogram meter square per second square. That term is here. So this is the relation between joule and erg. Now last part is the work done by the force of gravity. Work done by the force of gravity. As I will leave it from here. So this body have its mass. It have its acceleration due to gravity with which it is falling down. That is acceleration of this body. That is equals to acceleration due to gravity. So you people, I think so know what is the acceleration due to gravity. If we will leave any object from any certain height, it always comes down because of the gravity. Because Earth have the tendency to attract all the object towards its center with a certain acceleration. That acceleration is called acceleration due to gravity, or that force is also called as the weight of the body. That force is also called as the weight of the body. So we know, since work done is force into displacement. I can draw the diagram for it. Suppose I am going to leave any bodies from here and it comes down. And this is the ground. It comes to the ground. This height is h. H is the height. So of course the body is initially at this and it is falling within with a certain acceleration due to gravity, that is g. So at this position, weight of the body is mg, which is the force. So force is weight of the body. Weight of body into displacement is kind of height. So weight of the body is mg into height is h. So overall it becomes mgh. This is work done. Okay, so this is the end for this lecture. Thanks. Please like, share and subscribe this channel.